Hello, welcome to 11.4 Pyramids and Cones. Okay, so let's talk about a pyramid and a cone for a second. So if the cross sections of a pyramid and the cone have the same area, then they have the same height, and that means that the volume is the same. So on the left we have a pyramid. Do you see that it has a polygonal base? That's a pentagon, right? And on the right there is not a there is not a polygonal base, it's a circular base, which makes it a cone. But if those bases have the same area and they have the same height, then they have the same volume. Okay, this is Calvari's principle, just in a different form. Okay, so let's go ahead and develop the formula for the volume of a pyramid. So we're going to start with a triangular prism. That means the volume equals the area of the base times the height. And if I take out a third of that prism, where now I have a pyramid that has a triangular base, I am going to have a third of that prism. So three pyramids can fit into one prism. So here would be the middle section, where before I showed you the top, and this would be the bottom section. So a third, a third, a third. Right? So I'm trying to prove to you that three triangular pyramids fit into one triangular prism. Let me show you a different way to where I stack those pyramids. All three fit in the same prism. Okay, so hopefully I proved it to you with pictures. Obviously not a proof, but example. Okay, so the volume of a prism is a third of the product of the height and the area of the base. So our first steps in finding the volume of a pyramid are going to be the same as if we had a prism. We're going to find the area of the base first, multiply it times the height, and then either divide by 3 or multiply by a third. That is exactly the same step. The only difference in finding the volume of a cone is that the area of the base is the area of a circle. So we can replace the big B, the area of a base, with pi r squared again. Again, it's really the same exact formula. A third base height. I'm just, instead of big B base, I am putting in the formula. So let's work through an example finding the volume of this cone. So I start with the volume of a pyramid, or again, the volume of a cone is the same, where big B is pi r squared, where r is 4, and the height is 7. Now here is a trick. A lot of practice problems we're going to work are going to give you the slant, and so we're going to worry about the slant later. But remember, the height is from the top of the cone, or the vertex, and it's a 90-degree angle down. So these are right angle cones. So if I have an oblique, I need to use an altitude. So let me continue simplifying what we have here. So 4 squared is 16, times 7 is 112, and that's all going to be divided by 3 times pi. So this is as simple as I can get without an approximation. So my approximation is 117.3 units cubed. I gave you 3 practice problems, so just keep in mind that you need to get the radius. If I give you a circumference or a diameter, you need to solve for radius first, and then find the area of the base times the height. And I will see you in class. Don't forget to email it.